Hello, welcome back to our video. Welcome back to our class, Physics 101. That is Introduction to Physics. From the previous video, we looked at physical quantities and we said a quantity is anything that can be measured at a lab or through calculation. We said a physical quantity is the property of a system which can be measured numerically and assigned a unit to it. And we also said that a quantity, we have two main types of quantities. Now we made reference to the fact that other materials or other books make it four. So we looked at base quantities or fundamental quantities. We looked at derived quantities. We looked at a scalar quantity and then a vector quantity. Now, we said that a base quantity or a fundamental quantity is any quantity which cannot be derived from any other quantity. In other words, it forms the building block or the basis for all the other quantities to be built upon. And then we also said that a derived quantity is any quantity that is obtained as a result of putting two or more base quantities together, right? And then we moved a step further and talked about a scalar quantity. We also said that a scalar quantity is any quantity that has magnitude but no direction. And then a vector quantity is any quantity that has both magnitude and direction. This is what we spoke of during the previous video. And so today we are going to look at a very simple example. We are just going to apply what we learned the other time. So on the board here, we have the classification. It's a simple exercise, a simple word task that we are going to do to see whether indeed we understood the concept. We said classify the following quantities under fundamental quantity and then derived quantity. Now, I defined a fundamental quantity and I also defined a derived quantity. Now, the clue is, if you think it's going to be a problem, right, first try as much as possible and then come out with the derived ones. Now, in order to know that a quantity is derived, you should know its mathematical expression. And so, that would rather make it much more easier. But if you follow the previous video, all these examples that I put on the board, I categorize them, I classify them under some type of physical quantities. And so we are going to do this simple exercise. And so on the board here, we have area, mass, length, speed, temperature, density, power, time, acceleration, and electric current. There are a lot more, but we want to focus on these ones for now. And so, when you look at these ones, area, what is the definition of area? Now, area is the product of two lengths, right? Area is the product of two lengths. Length is a base quantity. Distance is a base or fundamental quantity, right? So, in order to group them, area is length times length. And if you are multiplying two fundamental quantities, then area becomes a derived quantity. I hope you understand. And so I'm going to put area there. And then anytime we pick out a quantity, I'm going to cross it out, so that you know that that one has been taken care of. And so area is a derived quantity. And so area is out. Now the next one is mass. Now, mass is the measure of substance. The measure of substance contained in a body. Okay? The measure contained in a body. Sorry. And so mass, it's still mass. We don't have any definition, mathematical definition or interpretation for it. And therefore, it makes mass a fundamental quantity. I hope you get it. And so there we go. Mass is a fundamental quantity. Then we spoke of length. If you were paying close attention, I explained area as length times length. 2 lengths makes an area. 3 lengths makes a volume. Okay? And so length here becomes a fundamental quantity. And so I put this one also here as well. Length. I hope you are following. And then speed. Speed. So mass, length have been taken care of. So speed. Now speed is defined as distance traveled per unit time. Distance already, or length already, is a fundamental quantity. Time is also a fundamental quantity. So the ratio of distance or length to that of time, or to make it easier, length or distance divided by time gives you the speed. And therefore, since we are making reference to 2 fundamental quantities, then speed becomes a derived quantity. I hope you get it. And so speed becomes, so now that one has been taken care of. Temperature is a measure of the degree of hotness of a body on a chosen scale. Now we don't know any other mathematical formula for temperature except the definition, that's it. And so temperature here is also a fundamental quantity. So temperature is a fundamental quantity. So temperature checked. Density. The next one is density. Density is defined as the mass per unit volume of a substance. Mass per unit volume. And so the mass, which is a fundamental, volume is 3 lengths, the product of 3 lengths, which is already a derived quantity. Are you getting it? And so mass divided by volume, giving you density, makes density a derived quantity. I hope you understand that. So density falls under derived quantity, and therefore density is taken care of. Now the next one is power. Power is defined as the work done, okay, the work done per unit time, or the product of force and distance. The product of force and distance. It's also known as what? Force and distance per unit time. Okay? The product of force and distance per unit time. Or force, the product of force and velocity. That is if you're talking in terms of mechanics. Okay? If you're talking in terms of mechanics, then we are using the velocity. Velocity is already a derived quantity. Alright? Mass. Force is also a derived quantity. So when we have 2 derived quantities coming together, they form another derived quantity. I hope it's okay. And so power now falls under derived quantity. So power, I'm going to put it down here. Alright? So power, checked. Time is also a base quantity, which is also a fundamental quantity. So I'm going to put time also here under fundamental. Time check. Acceleration is the time rate of change of velocity of a body. The time rate of change. So mathematically, acceleration is velocity divided by time. Velocity is a derived quantity already. So a derived quantity divided by a fundamental quantity gives you a derived quantity. I hope you understand. Good. And so acceleration A, this one also falls under. So acceleration. Then the last one, electric current. Electric current. Now, current is simply the flow of electrons or charges within a conductor. All right, the flow of charges from one point to the other within a conductor in 1 second. Okay, the flow. So we are looking at, but then electric current here is not a derived quantity. Rather, it's a fundamental quantity. Okay, now don't forget we have 7 fundamental quantities. We have a number of derived quantities. And when it comes to fundamental quantities, we have just 7 of them. And they are time, mass, length or distance. Okay, we have amount of substance, making 4. We have temperature, making 5. We have electric current, making 6. Then the last one is luminous intensity, making 7. I repeat, we have 7 fundamental quantities: mass, length, time, temperature, amount of substance, electric current, and then luminous intensity. These are the 7 main fundamental quantities. Don't forget them. Don't forget them. It will go a long way to help you when we start talking about dimensions of quantities. Okay? Very good. So the very last one, electric current, falls under fundamental quantity. And so electric, sorry for this one, or let me put it this way, current. And so electric current also checked. And so in effect, we have been able to group the following quantities under fundamental and derived quantities. Okay? And so you see, it was very, very easy. If you follow through what I teach you, if you follow through our lesson, these things will be at your fingertips. And that is all there is to it. As I said earlier on, physics is fun. It's not difficult. But then if you don't practice, then it becomes difficult. Because anything that you practice continually becomes part and parcel of you. But then if you don't practice, then anytime you pick it up, it becomes very new. And then you have to go all the way back to the beginning to understand the concept. I hope you've understood what we've just done. In our next video, we are going to look at the other type of quantities and how to group them at the quantities under scalar and vector quantity. This has been your teacher K. We'll meet again in our next video. Have a nice day. Bye.